Hi everyone, I'm Wenchen Fan from Databricks. I'm an Apache Spark committer and PMC member. And today I will present you the new API interface for data in Spark 2.3. A little more about Databricks. Databricks is founded by the original creator of Apache Spark, and we provide our customer a unified analytic platform which unifies the data engineers and the data scientists for better working balance. Okay, so before we go into the new API, let's first define what is the data source. So Spark, as a general computing engine, it separates the computing and storage in its engine. So it only focuses on computing and leaves the storage for other systems in the ecosystem. So we need a bridge to connect the Spark and other storage systems in the ecosystem. So for example, Spark can read the data from HDFS, can read from Kafka, Redis, and HBase, Cassandra, or any other more. So this is the API did for the data source. Connect Spark and other storage systems. And actually, this is not something new in Spark. We actually have this similar API in other systems as well. For example, Hadoop has an API called input format and output format. And Hive has an API called 30. And Presto has an API called connector. So in general, the data API in Spark defines how to read or write data from or to a storage system. And actually, this API kind of has an initial shape in the early edge in the edges, the custom RDD. So when Spark first came out, we have the RDD API, and the users can define their own RDDs, like Hadoop RDD, Cassandra RDD, and HBase RDD to read it from different systems. And for write, they can just simply call RDD map to define a customer Java function to write the data to the storage. And actually, this way works well in the edge and edges because we only have the RDD API, and there is not much requirement for the data scanning and the writing. However, things change when we switch to the Spark SQL. We have the data in structured format, and we have the query plan to define what user want to do. And we have new requirements to define a data source. So let's take a look at these new requirements. So for the read side, the first and the most important thing is define how to read data concurrently and distributively. And RDD can only satisfy this requirement. And then because the Spark SQL has a query to represent the pipeline of data, so we also think about how to skip reading data if we have some filters in the query. And then we also think about how to speed up certain operations like upgrade, like limit, if the data can support them natively. And also, because Spark SQL defines its own data encoding, and which is not a Java object, so the data have to define how to convert the Spark data to its own data format. And also, we want the data source to report some extra information, like data stats, like partitioning, to help Spark make a better decision when we plan the query plan. And also, we want to support streaming as well, because starting from Spark 2.0, we have a new module, job streaming, which builds the streaming functionality based on the SQL engine. For the write side, we have some similar requirements. So first of all, we also want to write data concurrently and distributively. And RDD can also satisfy this requirement. And then we also want to meet the SQL standard, and we want to make the write operation atomic so that we don't have partial data in the read side. And also, because it's very common in the big data world that something failed, and we should be able to clean up the data if something failed. And also, same as the read side, we have to using the encoding to convert data, and we want to support streaming. So these are the new requirements when we switch to Spark SQL for data source. And thus, we have, starting from Spark 1.3, we have released an API for data source, that is the V1 API. So the V1 API actually is very simple. This is kind of a demo of the API. So for the V1 API, we actually have two levels of API in the read side. So we have an API called relation provider, which works like a factory that takes some information and returns a best relation. And the second level API, the relation, which have an interface to define the size of its data and also some mixing traits for different scan. So for example, we have a trait called table scan, which is a full scan, just return all your data. And we also have an interface, a pruning filter scan, which can support column pruning and filter push down for your data source. And for the write side, we also have a very simple API. Just give the data a data frame, and ask them to deal with it, to write it to their system. Okay, so the V1 API actually works well at the beginning because it works for the most common case, and it's very simple to implement, to understand. However, it has many disadvantages. So first of all, it's coupled with other APIs, other upper-level APIs. So if you look back at the API, the V1 API depends on SQL context, depends on RDD, depends on def frame. So both of them, all of them are upper-level APIs. And this actually brings us many troubles when we upgrade to Spark 2.0. As you may remember that in Spark 2.0, we add a new entry point interface, Spark Station, to replace the SQL context. And this means the V1 API also becomes deprecated because the SQL context is deprecated. So this means coupling with upper-level API will be hard for the API to involve. So next, with the V1 API, it's very hard to add more push-down support. So let's take a deeper look. So here in the V1 API, we use the build scan method to define the push-down. So for example, for scan, there's no push-down, and we have a build scan method with no parameters. And if we want to support push-down the filter and the column cloning, we have a build scan with 2 parameters. So let's think about if we want to add one more push-down support, like limit push-down, what we will add for the interface. So here is the result. We will have a new build scan method which takes the limit parameter, and also we will have a data start one support limit and column cloning, but not filter push-down. Then we have to add a new build scan method, takes limit and require columns. And we also have data start may support limit and filter push-down, but not column cloning. Then we have a new interface. And if we add more operator, we'll add a lot more of interface, which is really here. And the next, for the V1 API, it's hard to add different data encoding. So for example, for better performance, we provide a current scan interface to allow the data to return the data in chunk. This is also hard to do in the V1 API. So because the V1 API uses the RDD interface, and it just asks the build scan method to return RDD of low. So if we want to support current scan, we have to multiply, double the interface, number of interface to add a different table scan trait returns the RDD of current batch instead of RDD low. So this is also very hard to involve. And next, it's very hard to implement writing. So look at this API, just a data frame and overwrite flag. What I should do with this? So it's very hard for the data developers to think about how to implement the write. And the next, very obvious, there's no streaming support in the V1 API. So to fix these problems, in Spark 2.3, we start our work. Here is a summary of the requirements that V1 doesn't success to handle. So for the reading data concurrently and distributively, yes, RDD and V1 API can handle. And V1 API can also support filter push-down to skip data reading by filters. However, if we want to speed up certain operations to push down more operators, it's kind of partially supported because it's very hard to add a new interface for it. And also, for other new encodings, it's very hard, as I showed before. And for the extra information, we only have 13 bytes. And if we want to add more like data partitioning, it's also harder to involve the API. And also no streaming support. For the write side, so the first requirement is also satisfied. We can write the data concurrently and distributively. However, with the V1 API, it's kind of impossible to make a write operation atomic. There's no hint in the API. And also, if something failed, you have to clean up data. Also, there's no API for it. And also, add new encoding is also hard and no streaming support. So to solve this, in Spark 2.3, we start our work to design a new API for the data. We call it Data API v2. So here is a sketch for the v2 API and the read side. So now we have 4 levels of the API. So each level will create the instance of the next level. So the first level we call the base interface, Data v2, which can mix in different traits to indicate what function it supports. So for example, read or write or read with user-specific schema. And the first interface, for example, read support, have a method reader, which takes the information and returns the next level API, the data reader. The second level API, data reader, it can have a lot of mixing traits to support different of query operations like push down, like query push down, or like operator push down, like different scan for the different encodings, and like for reporting different informations like data stats and partitioning. And the third level and the fourth level API is actually just to simulate the RDD. We want to get rid of the RDD API, so we design something similar to the RDD interface. We have an API called input partition, which will be created by the Delta reader, and it will create a list of it to simulate a list of RDD partitions. And each input partition will have an interface to create an actual reader to return the data one by one. So input partition and input partition reader together will kind of simulate the RDD API in V1. And also, the V2 API is very easy to extend. So let's take a deeper look. So here we have a base interface, Delta reader, to implement the reading logic, which has a method plan input partitions to return a list of input partition. And also we have many mixing checks to support different functions like filter push down. So here is an interface supports push down filters to add support for filter push down. And if we want to add more features, for example, limit push down, it's just a one new mixing thread. We can call it support push down limit, and the Delta can mixing this thread to add this feature. And if we want to support different data encoding, for example, calendar scan, we can also justify a new interface, support scan calendar bunch, which can also be mixed in and supports the new data encoding by a different method to return the input partition. So we don't have the problem in the V1 that once you add a new feature, you have to add a lot of new interface in the entire API framework. So let's take a real example to see how the API works. So in the real world production, your data pipeline should involve three parts. The first is the Spark driver, which kind of generates the query plan and run it. And then you may have a external storage system to hold your data. And also Spark has a bunch of executors to actually run the task. So first of all, in the Spark driver side, we will have a query plan, which may be generated by the SQL statement or a data frame API. And then the query plan, the leaf node of the query plan should be a data scan node. In this node, during analyze, we will create a data reader, which is kind of the root interface of the read side. And this logic is implemented by the read support.create reader, which takes end user options. And next, in the data reader, we will probably connect to the external storage to get some information. And then we will apply the push down, and maybe we can ask the storage to see, hey, can you push down filter? Can you push down limit? Or something else. And finally, in the data reader, it will create a bunch of input partitions, which will be produced data for each output partition. And this logic will be implemented in the data reader with a lot of its mixing checks for different query operations. And next, the Spark driver will send a bunch of input partitions to the executor side, and the input partition will carry some information that is necessary to create a reader at the executor side. And this logic will be implemented by the input partition interface. We will probably have a custom implementation of it, and we will define some fields to carry the information, and we will have some logic in the method, create partition reader to define how to initialize your reader. And then at the Spark executor side, we have the input partition reader, and it should probably talk to the external storage and fetch data one by one, and the data will be later feed to Spark and begin to process. And this logic should be implemented by the interface input partition reader, and it's kind of like an iterator, has a next and a get method. And then let's talk about the right side. So the API is pretty similar to the read side. We still have 4 levels of API. So the first level also integrates what function you want to support. So here we want to support write support. And then the second level API is the data writer, which is kind of a pointer of your insert query, and then it will create your write factory. And then the second level API factory will be serialized to the executor and create the actual writer. Let's see more details with process. So first of all, similar to the read process, in the Spark Java side, we will have a query plan that is generated by your front-end API, for example, SQL statement, the insert into statement, or different writers API calls. And then the query plan, the root node of the query plan should be an insert node. And this node will create a data writer during analysis. And this logic should be implemented by the Rust support.create writer. And in this method, we have some information like job ID, which is used to avoid conflicts if we have multiple jobs writing to the same target. And we also have a parameter to define the schema of your import data, and also the save mode and the end user options. And here, the return type is optional, because if the data is already there and the save mode is not append or overwrite, the implementation can omit the write operation because the data is already there and we don't need to do anything for it. Okay, let's move on. So once we have the data writer, it will probably connect to the external storage and to do something to prepare your write. So for example, we want to avoid the write job conflicts, and we want to have a transaction. So we may want to do something like write a log, or we can apply a lock in the system. So this is something we can prepare for the first phase. And then the data writer should generate data factories for the next phase. And this logic will be implemented by the data writer.create write factory. And I will cover the commit and abort later. And the next step, the Spark Java will serialize and send the data write factory to the Excel side, which will carry some information to create the writer at the remote node. And this is the interface for it. And as we can see that this interface takes a parameter of partition ID because it will create a writer for each partition of your import data. And then next, at the Spark Excel side, when we have the data writer, it will probably talk to your storage system and write the data one by one. And here is the interface for the write logic. It's a simple write method with the record, and we call it one by one. And then next is a very important step. So if the data writer can write all the records successfully, and it should commit this task and send a message back to the driver. So here we can put this logic in the commit method. So it should probably probably call the storage system to do some commit and also construct a message and send it back to the Java side. However, if there's something goes wrong and we have some records fail to write, then we should abort this write task. And the exception will be propagated to the Java side, and the data writer will also notify the storage system to say, hey, this task fails. You should abort and clean up your data. And this logic should be put in the abort method. Okay, so finally, let's go back to the Spark Java side. So Spark Java side will keep track of all the write tasks. And if all of them success, we will connect to the storage system and commit the entire job. And this logic should be in this commit method. However, if some task failed, and we should abort this job because we want to implement the all or nothing semantic in SQL. So here we will probably connect to the storage system and ask it to abort the transaction and clean up all the data, including the data that was written by the previous success write tasks. And here is the API for it. So also for the V1 API, we support streaming. And for time limitation, I will not cover them here. And if you are interested, you can take a look at these two talks for the job streaming and the job streaming continuous processing. We still have many ongoing improvements for the API. So first of all, we found that the data source is more than data. So some data source have other information like the metadata. So for example, Hive, it has the table definition and other things like partition information. So in Spark side, we want to standardize the DDL logical plans And when users run some DDL commands in Spark, we can proxy them to the DDoS so that we can integrate the DDoS catalog. And this is tracked by this JIRA. And also, we want to support more pushdown for operators. So here we want to support limit pushdown, and upgrade pushdown, and join pushdown. And these are tracked by these 3 tickets. So if you're interested, you can take a look of these tickets. Okay, thank you, that's all.
We have time for a few questions. If anybody wants to ask any questions, I'll walk around the room with the mic.
Hi. I'm not sure if I understand correctly, but you said the data source V1 doesn't support atomic write, and as I understand, Spark it's only available. V2 is only available in Spark 2.3, right? Does it mean in Spark 2.2 structured streaming, we cannot have end-to-end exactly one's consistency with V1 writers?
So V1 API is too simple to support atomic write, and you can do it with some very complex logic in your customer Java code, and it's doable, but it's very hard because the API has no hint. Just a def range, you have to call something map, or you can have to do some custom field handling and something.
Yeah, quick question about writer interface. I noticed that it's write records one by one. Is it going to be like implementation specific? You need to create a special buffer to batch that? Because for most storages, it's not super efficient to write one by one record. You probably want to combine them in batches.
Yes, so currently we haven't have a plan to add the current write support yet. And we just make it possible in the API, but doesn't mean you have to do it.
All right, and the second question is about aborting. So who's responsible for commit and abort? Is it executor or driver?
Both.
Oh,
so
okay.
think about if the task failed and retried. So we have to have a task level commit and abort. And if some task failed and some task success, we also have a job level abort and commit. So both.
Okay, so if executor fails and cannot send anything, driver gonna abort the whole thing.
If executor failed, we should send a kind of signal to the stock system, and Spark will retry the task 3 times. So we have to ask the storage system to abort this certain task, and after retry all fails, we abort the entire job, large job. So we will need both.
Got it. Thank you so much. It was a great talk.
Thank you.
Question right here. You have quite a few questions, Wenchen.
Hey, Wenchen. I remember trying in Spark 2.0 or 2.1 to read a table using the JDBC reader into a data frame. And I did something like, read.jdbc .limit1. .limit?
Oh, limit 1.
.limit
okay.
1. And I remember seeing that get compiled down, and what would actually happen in the database was the whole table was being read into Spark.
Yeah.
And then Spark would just give me the one row I asked for. So my question is, in the data source V2, I noticed here we have limit pushdown. Does this mean this problem will be fixed?
Yes.
And when I say limit 1 on the data frame,
yes,
it'll actually turn into a query that only gets one row from the database?
Yes.
Excellent. Okay, great.
Any other questions for Wenchen?
It's really hard to find documentation. That's a wish list. There's good documentation for the API, new API.
Sorry, can you repeat?
There is no documentation for V1 and for V2 as well. And it would be nice if you also spend some effort on writing documentation for the API.
Oh, yes. So for the V2, we really pay attention to this. So we have a very long document in the API definition, Java doc. So if you are interested, take a look at the source code.
Another question. You have in Databricks this Spark XML library. Is there any plans to implement the data source version 2 for XML?
So V2 API is only alpha released in Spark 2.3, so which means it's still unstable now. Maybe we have new improvement to maybe break the API. So there's no guarantee that the API is stable now. So we are trying to make it stable in the next release. So for now, maybe wait a little bit for the XML package.
So when is this going to be available, one? And number two, is this going to be available for Python APIs as well?
Oh, so I think the others will, so I feel I think Java API is good enough for the data because you won't have many people to write the data, right? You will have a kind of one team, the data team, to write it, and they maybe can only do it in Java, and the Python people don't need to care about it. Because there's no custom logic. Maybe it's reasonable to have a Python UDF, but for data source, I think just Java version is good enough. And you just find one Java people to write the data source, and that should work. Well, currently, no, we don't have a plan for the other language.
Hey, what type of statistics are supported in the new API?
What?
What kind of statistics?
Oh, static support?
Statistics, yeah.
Yeah, so we already have it, the API in the Spark 2.3. So for low count, for setting bytes, and for something like non-count, or I don't remember. But we do have an API now. We just a lack of implementations. So we are trying to move all the built-in data to this new API.
I see. And what data sources are supporting the statistics?
To what?
Which data sources are supporting the statistics?
Oh, for example, Packet. Packet has a low count in the Packet file filter. So we can, for example, keep the filter, keep the scan filter and get all the low count information and get the final count of your entire table. So it's possible to do in Packet and other file formats as well, I think, current format.
I use data source V1. So what is the plan for any deprecation? Like
What?
I use data source version V1, right? So I want to know, do you have any plan to deprecate V1 since we are taking V2?
So V1 will still be supported for a long time. So we won't remove all the APIs, just add new APIs. So you can still using your old code to run V1, and it's okay. And if you want better performance, you can try to rewrite your data source to use V2 API.
Thank you very much, Wenchen. Please give him another round of applause.